Welcome to another one of our videos from Chapter 10 dealing with linear regression. This one is particularly about that regression equation. The regression equation is used to predict values based on a given data set. There are many different regressions. We are looking at linear regression, straight line regression. So we're looking to approximate a data set using a straight line, which means in our case that notation will be y prime equals a plus bx. You might recall y equals mx plus b from algebra, where b here was your intercept. And your m was the slope. So for any straight line, you had an intercept and a slope. For our example, b is the slope, not the intercept. A is the intercept. So you have to make sure that you're recognizing which one's which when you're looking at the formula. Also, note a y prime here as opposed to just a y over in this other equation. Y prime means predicting. Y means equals. They are precise values over here. We are looking at predicting those values. That's what this whole section is concerned with. Now with our y prime equaling a plus bx, again we're going to have formulas for a and b. And b. My suggestion, calculate first your b value. B being for our regression n times sum of xy's minus the sum of the x's times the sum of the y's. It's the exact same numerator as what we had with our r value. The denominator now is that same little piece though with the x's only. The y is not included in this particular formula. Okay, now for the a formula, the textbook formula for a is sum of the y's times sum of the x's squared minus the sum of the x's times the sum of the xy's. All of that over n times the sum of the x's squared minus the sum of the x's quantity squared. which is algebraically equivalent to what I'm going to show you in just a minute. Mine is based on the idea that y equaling a plus bx. That's the formula that we're looking for with a y prime. Well, if we solve for solve for a, you get y minus bx equals a. All you have to do now is make that y bar over x bar, which is the sum of the y's over n minus b times the sum of the x's over n. That's the formula I use because it is to me more realistic or more intuitive because of the straight line equation. So you will see me using the form a equals sum of y over n minus b times sum of x over n. If you use the other equation up there, that's fine with me, as long as you're using a true equation and coming up with the right solutions. For our sample problem, we're going to use that practice problem that we had before. The reason for that is you've already got the data entered into your calculator, and you already know what those particular calculating values are that you will need. So based on that, if you need to pause the video, enter the data again, then we can go from there. So once again, we need a y prime equals a plus bx, and we need to calculate b first. B is n times sum of the xy's minus the sum of the x's times the sum of the y's, all of that over n times the sum of the x's squared minus the sum of the x's quantity squared, which in our example is 6 times sum of the xy's 1128.88 minus our sum of x's 395.81 times the sum of the y's 16.49, all of that over 6 times my sum of the x's squared, which is 27,961.82 minus the sum of my x's 395.81 squared. Reading that off of the calculator, just like we did for our R value, you will get 0.022. So that's our slope of this particular equation. When we get ready to calculate A now, again, I'm going to use the y bar minus b times x bar, or sum of y over n minus b times sum of x over n. Substituting in our sum of y, 16.49 over n, which is 6, minus b, which we calculated to be 0.022, times our sum of x's, 395.81 over 6. Again, going to the calculator and just looking off our screen, 1.28. So those are the values. Now my equation, to finish this off, y prime equals 1.28 plus 0.022x. That would be the finished work on that problem. As I'm looking at checking on things, I would be looking, yes, you've identified that you're going to be doing a regression equation. Yes, you have your notation. Yes, you have your formula. Yes, you have your substitution. Yes, you have your answer. Yes, you have your notation. Yes, you have your formula. It can be this one or it can be the other one that you got from the textbook. You have your substitution and you have your answer. Then to finish it all out, I double check that you have a prime notation, meaning an approximated score. You have your correct values here in the right locations, and that you've got that x on there. You haven't written it as y equals 1.28 plus 0.022. You've got to have that piece right there. Those are the parts that I'll be looking at and concentrating on. So as you're doing your homework and then eventually taking your exams, you'll know what pieces are important.